Yes, hello Divine. How are you doing? I hope you are doing great. Luckily, I have been able to fix my system and ready to provide the solution to the question you asked earlier. Let me start with the first one. This question that has to do with this particular one. It says an isosceles triangle ABC has its vertices on a circle. If the length of line segment AB is equal to 13 centimeters. The length of line segment BC is 13 centimeters and AC is 10 centimeters. Calculate the height MD of the triangle and the radius of the circle to the nearest whole centimeters. Uh, Quickly, let me see how to solve this problem for you to see. Let's pick this and see how I'm going to provide a solution. Okay, so quickly, I'm going to import the question here, so I'll solve it bit by bit for clarification's sake. So let me try and check if I can drag the question from this platform to oh good. Wow, this is it. All right. So to solve this type of problem, it's highly recommended that you try as much as you can to create the diagram, produce a diagram for the question. So let's see if we can get a sketch of the diagram. So we have a triangle A, B, C. Don't mind my sketch, might not be too neat. Triangle A, B, C. So here is A, vertex A, vertex B, and C. Okay, an isosceles triangle ABC has its vertices on a circle. So I have to draw a circle outside the triangle. So it means the triangle is an inscribed triangle in the circle. Something like this. All right. So the length of the sides of the triangle AB is 13 centimeters. BC is 13 centimeters. While uh, the line segment AC is 10 centimeters. Okay, so calculate the height. The height of the triangle is the line from the vertical angle down to the base, which forms 90 degrees with the base. It's right angles to the base. So this is point M. Here is point M. So this is how the sketch should look like. All right, so to solve this problem, we shall apply the first theorem in this section. If you check through the textbook, I think that is theorem 10, and that theorem is referred to as the midpoint of a chord theorem. The theorem states that if a straight line is drawn from the center of a circle to the chord, which is not a diameter in the circle, the line will be a perpendicular bisector of that chord. Now, by applying that theorem, since this line passes through the center of the circle, that means the line must be a perpendicular bisector of the chord, meaning that it's going to form 90 degrees as we've seen, and also it will divide the chord into two equal halves. So this should be 5 centimeters, and here should also be 5 centimeters. This AM is 5 centimeters, while MC is also 5 centimeters. So we can easily sketch out this right angled triangle, because there are two right angled triangles formed. So you can sketch this out. Now if you sketch that triangle out, it's going to look something like this. Don't mind my sketch, just bear with me. This is a freehand sketch. So here is 5 centimeters. This is 5 centimeters, while this length is 13 centimeters. Don't forget, this point is point B, while this is point C, and here is vertex M. So the question, to answer the first question A, it says calculate the length DM. So of course, this is a right angle triangle, and we know, and solving a right angle triangle, the length of any side of a right angle triangle, the best theorem to apply is Pythagoras theorem. So I'm going to be applying Pythagoras theorem here, which states that the length of the square of the length of the longest side, which is the hypotenuse, is always equal to the sum of the length on the other two sides. BC squared is equal to BM squared plus MC squared plus MC squared. Okay, so please bear with me. I'm strong with my mouse. So BC is 13 centimeters, that's 13 squared. BM is the unknown length about solving, while MC is 5 centimeters plus 5 centimeters. So when we do this, we simply collect like terms. That is 5, we take it to the other side. 5 centimeters is positive. It's going to move down to this side, take like terms, that is subtract 5 from both sides. If 5 comes to this side, it becomes negative. So then that is therefore BM squared. I'm moving 5 to the left as I'm subtracting 5 from both sides. BM squared is equals 13 squared, and 13 squared is 169. 169 minus 25. 13 squared minus 25, and that will give 144. So BM squared is equal to 144. So therefore, to solve for BM, which is our consign, we apply square root to both sides. And when we apply square root to both sides, BM, the length BM, the magnitude of BM will be equal to the square root of 144 plus or minus. But since we are dealing with length, we are interested in just the positive of this value. Hence, the value is, the magnitude of BM is 12 centimeters. I hope this is clear. 12 centimeters. I hope this test is very clear and precise. Okay, so having done that, we'll be able to answer question A. Now, left with question B, which says the radius, calculate the radius of the circle to the nearest whole number. Or to solve that problem, what we actually need to do here is to look at the radius. So don't forget that the radius is a line, a straight line from the center of the circle, from the center of the circle to a point, from the center to a point at the circumference. That is a line that comes through this point and from the center down through this point. And do not also forget that the length of all radii in a circle is equal. That is, this length is equal to this length and is equal to this length. Of course, because here is also a radius. And we've solved for the length of this, the height of the triangle as 12 centimeters. Okay, I don't want to make this rough. Let me just bring out the triangle from the circle. So you see how it looks like. So something like this, something like this, and here is 13 centimeters, while this is 13 centimeters, and this length is 10 centimeters. Okay, and we have the vertical line, which is perpendicular, and this is 5 centimeters, and here is also 5 centimeters. Okay, I hope you're following. And here's the center of this yes, the center of the circle, and I draw a straight line from this point to that center. That will give us a radius, and this is another radius, and this length is 12 centimeters. The whole of the length is 12 centimeters. And I said this length is equal to this length is equal to this length. So we have 3 isosceles triangles in this single triangle. If you check it out, I have this triangle 1, this other triangle is an isosceles triangle 2, this other triangle, another isosceles triangle 3, with the main isosceles triangle 4. So what I want to do right now is to extract one part of this right angled triangle. That is, I want to extract one of the parts, this part of the right angle triangle, the same part we dealt with initially, this particular one. So I'm going to extract it out with the height that we've calculated. So I'm extracting that part, and I want you to pay attention to what will happen next. Okay, so the part is going to look like this. So here is the here is the right angle triangle that has been extracted, and at this point, you see you have here to be 12 centimeters, and this is 13 centimeters, while the base is 5 centimeters. Don't forget, we divided the 10 into 2 equal parts according to Theorem 10. And don't forget, we have a line from which is the center of the circle to this point, which is the radius, and this line is equal to this line. So here's just a rough sketch. Don't mind my sketch. Okay, now the problem now is what is calculate. The question says calculate the radius of the circle. So to solve for the radius of the circle, what we simply need to do here is how do we go about solving for the radius? All right, let's strategize and see what will happen. So how about if I decide to call this length from this point, if I decide to call this length from this point to this point, I call that length x. If I label this length x as x, that means this other length, which is the radius, will be x minus 12. Do you agree with me? That will be x minus 12. Oh, sorry, rather 12 minus x. 12 minus x, because the whole length is x. So this is 12 minus x. And in the same way, this length will also be 12 minus x. That's it, because the length of all radius in the circle are equal. So, and I'm going to be looking at this right and the smaller right angled triangle. If I do that, I'm still applying Pythagoras theorem. Then we have 12 minus x, 12 minus x all squared, according to Pythagoras theorem, the square of the hypotenuse side, and 12 minus x is the hypotenuse for the smaller right angled triangle, is equal to the sum of the length of other two sides, x squared minus, or plus rather, x squared is equal to x squared plus 5 squared. X squared plus 5 squared. Okay, so When you open the square root, expand. Now expand by expansion. I have x 12 minus x times 12 minus x. 12 minus x times 12 minus x. 12 minus x. Bear with me. My writing is so poor because I'm struggling with my mouse. Equal to x squared plus 5x. So if you have this, the next thing you're going to be looking at is how do we expand? So 12 times 12, that is 144. I'm expanding 12 times 12, 144. Multiply 12 by minus x, that is minus 12x. Then x times minus x times 12 minus 12x, and now when you add them up, that will give minus 24x, minus 24x, and minus x times minus x is plus x, plus x squared rather, plus x squared equal to, that is equal to x squared, x squared plus 5 squared. Okay, so when you do this, the next thing we're having is this x squared plus x squared plus x squared. When this comes, it becomes x squared minus x squared. Now we'll take off this to factor it out. So what do we have left? We have 144 minus 25. 5 squared is 25. Subtract 25 from both sides. Equal to 24x. Equal to 24x. So brought this over to this side. I will take this over to this side. So that is subtracting 5 by 25 from both sides and adding 24 to both sides. So subtract these, 144 minus 25, that will give 100 and okay, 144 okay. So that will give, let's add that, let's subtract that, 144 minus 25, that is equal to 119, 119 over 24, equal to 24x, 24x. Divide both sides by 24 over 24 over 24. So 119 divided by 24. That is so fact this, you cancel this, and then this should be 4.9. 4.9 equals x. All right, and I hope all right, so we have x equals 4.9, which is approximately to the nearest whole number, x equals 5 centimeters. So since x is 5 centimeters, that is that 5 is the length of this smaller right angle triangle. But the question is to calculate the radius of the circle. So the radius of the circle is 12 minus 5. So radius r is equal to 12 minus 5, which is equal to 7 centimeters. I hope this explanation is clear enough, and I believe you understand it. So please take your time, watch it again, over and over again, and you will get to understand every bit of the steps I take. Thank you, and please keep studying. God bless you.